Okay, let's think about ocean lights now. So they're mostly the lights you see when you're out in the boat on the ocean, of course. So throughout the world, all coastlines that can be navigated are lined with lighthouses and lights. There are going to be three main categories of lights. Number one, the long-range ocean lights, commonly known as lighthouses. Number two, coastal lights. They're the shorter-range lights used for indicating harbours and rivers. Three harbour lights, including buoys and beacons, and indicating channels and hazards. Now, most lighthouses have a lens that concentrates the light. This concentrated beam is then rotated at a set speed. The rotating beam can often be seen as a flare or a loom across the sky, even though the light source is below the horizon. A vessel that has been well off the coast must be able to distinguish one lighthouse from another to ascertain its correct position. Consequently, these lighthouses flash at different rates. A light in which periods of light are shorter than dark periods is marked as F1 for flashing on a chart. If the periods of light exceed the periods of darkness, then it is marked OCC or occulting. A lighthouse emitting two short flashes of light followed by a long period of darkness is marked F1, 2. Three long flashes of light followed by a short dark period is marked OCC 3. The length of the cycle in seconds is also given, followed by the height of the light above sea level and its range in nautical miles. The chart shows the lighthouse at Point Lookout, North Stradbroke Island, marked on a chart as F1, 3, 15S, 78, lowercase m, 10, large m. This also means that the light gives three short flashes and a long period of darkness in each 15-second cycle. It is 78 metres above the mean low water mark and has a range of 10 nautical miles. Because no light anywhere in the region flashes in a similar fashion, even an off-course navigator could readily establish position if charts were available. Now, just a note on the two m's. Just think of the lowercase m as meters and the uppercase m as nautical miles. So that's a little bit of a trick there, but that's an important one to remember. So I'd like you to copy these notes into your books, please, folks. The Lighthouse and Navigation is the title. Lighthouse lights are either flashing, F1, or occulting, OCC. A flashing light gives a number of short flashes of light followed by a long period of darkness. A lighthouse marked OCC refers to a light which gives long flashes of light followed by a short period of darkness. F1, 2, 14S, 108M, 13 large M describes a lighthouse that has two short flashes of light followed by a long period of darkness every 14 seconds. It's 108 metres above sea level and has a range of 13 nautical miles. The other maths that you'll need to be familiar with for the problem coming up soon is that of tangent ratio for trigonometry. So the tangent of an angle is opposite divided by an adjacent. We also need to know that 1 degree is the same as saying 60 minutes. The angle of elevation of a lighthouse is the angle measured from the horizontal upwards to the light. And 1 nautical mile is equal to 1,852 meters. So let's have a look at an example. A lighthouse is marked on a map as F1, 3, 15S, 78M, 10, large M. A ship's navigator using a sextant measures the angle of elevation at 1 degree and 30 minutes. I'm going to ask you to describe the flashing pattern expected, how high above the sea level is the lighthouse and what range of light is emitted from it, how far is the vessel from the lighthouse. You need to give your answer in meters and nautical miles, And what is the angle of elevation if the vessel is half a nautical mile from the light? So let's look at the flashing pattern and the height above sea level. And the range. So it's an F13, so there's 3 short flashes of light and then a long period of darkness. It's a 15-second cycle, so that happens every 15 seconds. It's 78 meters above sea level, and the range is for 10 nautical miles. So how far is the vessel from the lighthouse? We need to give our answer in meters and in nautical miles. So we really need to draw the triangle, PLH. So P for the vessel's position, H you can think of as sea level, so the bottom of the lighthouse, and L for the top where the light actually shines from. So P is the vessel's position, LH is the height of the light. In this case it's 78 meters, so we draw that on the triangle. The angle of elevation, which is the angle HPL, is 1 degree and 30 minutes, and that's the same as saying 1.5 degrees. HP is the adjacent side, and 78 meters is the opposite. So we're going to use SOHCAHTOA here, and of course that's trigonometry. So let's substitute the knowns into the tan of the angle equals opposite over adjacent. So we know that the tangent of 1.5 degrees equals the opposite over the adjacent there. And that's what we have indicated on that line of working. We need to rearrange that just to say that the adjacent, or HP, equals 78 meters divided by tan 1.5 degrees. And if we put that into our calculator, that's 2,979 meters. But we also need to convert that to nautical miles. So we just know that there's 1,852 meters per nautical mile. So we're just going to say 2,979 meters divided by 1,852 meters per nautical miles. And that's going to give us 1.61 nautical miles. Now let's think about the angle of elevation. So it's really good to draw the diagram. And then we can write in the what we know from the question into the diagram, and it helps us visualize the problem so much better. So it's highly recommended you do that. So we're thinking of the angle of elevation. So that's the horizontal, and looking up there. So that's us looking up if we were at the vessel's position. So the unknown angle is E. The opposite side is 78 meters. The adjacent side is half a nautical mile. And we can convert that into meters, which is 0.5 times 1,852 meters per nautical miles. And that converts it to 926 meters. So it's good old tangent ratio again. So the tangent of the angle is the opposite over the adjacent. And in this case, we know that the tangent of E here is got to equal the opposite over the adjacent. And that's what we've done over there. Now we know that the tangent of E has got to be that. So to work out the number of degrees or the magnitude of the angle E, we're just going to go Shift tan, open your brackets and use your fraction function, folks. It's just going to be 78 over 926 and close your brackets. And that should get us 4.8, which is 4.8 degrees.